Hi, good evening. I'm Luis Barbosa, Solutions Architect Manager here at Morange Digital. And I'm going to talk here today a little bit about the evolution of Snowflake application layer, in particular, its availability with Streamlit. So let me share my screen. So as you probably know, Snowflake was originally conceived as a full-blown data warehouse. Probably his main feature is the coupling of the processing layer and the data layer. But in the most recent years, what evolved most was the application layer. So on top of this sophisticated data house structure, now have several different application features tightly integrated with the data warehousing. It started with something as simple as custom functions from SQL queries into different languages as Python and so on, up to the point as we're having powerful libraries, even AI and machine learning libraries. And from that, custom applications are made available, even like Document AI, Universal Search, Copilot, and so on. Just until recent, it started supporting container runtime environment, so it's possible to encapsulate your application as a container, deploy it to Snowflake, and run it from there, directly integrated with your data and minimizing data traffic, right? Not only that, more recently, it started to support LLMs, so it's possible to have custom or pre-deployed LLMs as container, use it to integrate in Snowflake. But today we're going to focus here on the Streamlit capability. So one type of application that's currently supported are Streamlit applications. So you can create a whole user interface, deploy it directly on the data house, and from there, we can access directly the data, minimizing data traffic, and of course, enhancing performance and minimizing latency, right? So let's start with a few examples, what type of graphs you can define and can use here. Have simple examples, mainly target or using as reference the financial market and insurance companies. So let's start with a simple example. And here I have a table with home ownership data in US for the last couple of decades. And here we have a couple columns only, a column for year and a column of the percentage of homeowners, right? So from that kind of information, probably going to be very useful to create a line chart. So a line chart, you can see the trend. So here we go. So back in Snowflake, you can create your Streamlit app. It's one of the new components, right? That is Streamlit. You can create a Streamlit app. Just have to inform your warehouse that's going to use your process, the database that's going to save your application, and the schema that will also organize that application. And then as you create, it brings a template, a sample application as an example. It's started the Streamlit server and run it. So here it is the example. Let's quit all this example. Let's show our own example here. It's simple enough. I'm going to reference Streamlit library, Snowflake library. So with Streamlit library or Snowflake library, you can have access to the Snowflake session. And with the session, can run different queries. And the queries maps data already to our regular data frame. It's actually a Snowflake data frame. If you want to, if it's the case, you can convert to Panda data frame. But as it is, it's fine. And from that, we could, for instance, use the Streamlit library and write the data, the whole data frame through the screen as an output, right? Let's quit this last line here, run it. So we can see the very same data directly in the user interface. Creating can be used as an element to create dashboard reports and so on. In case I don't want to see this way, I want to see in a graph format. As I said, a line chart probably would be a very good idea here. And a line chart, very similar to what I have with Matplotlib, Seaborn, Altair, and our other visual libraries. We inform your data source, your data frame, what information you want to as x-axis, what information you want to as y-axis, and that's pretty much it, right? You want to see the percentage of home ownership evolving through time, through each year, right? You can run it, and here you have it. It's a very simple information, right? You can see a little bit how the home market decreased since the crisis of 2008 and regained tech tractions more recently throughout the pandemic. Let's try something else. Let's try another table. We can try a similar one. Try this one of life insurance. Very similar. Here we go. Very similar to the other one. Have several years and the percentage of people that own and don't own houses. So the difference here that's not counted the people that currently owns mortgages. So the mortgage houses are counted as a property of a bank. But anyhow, it's a very similar idea. We're gonna use a very similar code. The only difference is that we're gonna have a couple of y-axis information, right? The people that own houses and people that don't own houses. So the change is going to be minimal here. So as y-axis information, we're going to inform a vector of columns, not a single column, right? Very similar. And you can analyze both trends and see how around 2002, the number of people that don't own houses are larger than people that actually owns, and this trend seems to keep expanding that gap. That's I guess it's an interesting information, right? Let's try another one. Let's try some analysis for auto insurance. So as auto insurance, we have this other table here. You can have different premiums for our auto for each one of these states, right? For the last 3 years. All right. And so for this kind of graph, again, we can initially experiment with a line chart and have a different line for each state, right? Very similar from the last one. And you're probably going to perceive or observe a couple of outliers. So you see how auto premiums reduced after the pandemic, but anyhow, we definitely see a couple of outliers here. So this light blue here, it's Michigan. Here it is, Michigan, and the purple one, it's Florida, and Florida was the second outlier, but just recent it decreased for a level that's equivalent to many different states, something less than 1,500. And of course, Michigan at some point were close to 6,000 premiums per year, right? I had another variation of this table or different view for this table. It's more or less information, but more details specific for 2023. So I have each state, the main city, population, latitude, longitude, and so on. And you could, for instance, compare each one, and throughout all those lines, we could see the trend from 2021 to 2023. But if you actually want to compare each one of the states, it's going to be hard because all the lines were condensed in a single point. Probably a very good graph to enable this comparison would be a bar chart. So let's try something else. And here on our code, we're gonna use now a bar chart. And again, then I'm gonna compare each state, and as the y-axis, what's the premium for each state, right? And again, of course, we're gonna see Michigan as outlier here for 2023, even it decreased from 2021. But anyhow, we see other states, and even Florida became close to the two others, right? Florida premium, it's a little over $1,000 per year, with other couple states around that price range. So as we now have each state separation by region and by division, we could have aggregation, right? Sometimes it's hard to see each one of the states here, have 50 different states. We could aggregate by region, if it was the case. This aggregation, this kind of aggregation, we could do as aggregation functions directly on SQL, or you can use regular aggregation that's available on pandas and data frames, right? The syntax for Snowflake pandas is a little different from pandas data frames, but it's close enough. So we do a group by a division, it's a subsection of a region, right? And calculate the average premium per division, right? And then we can show this average premium throughout division on this aggregated data, again, using a bar chart. Here it is. So you see as North Central, and of course that's East North Central, as it comprises also Michigan here, the largest values. In the other couple of other region or division actually, like Mid-Atlantic and South Atlantic, are also with values close to, on average, $800. Right. As a last example, we're going to use the geographic information that we have here, as we have the state, the capital of the state, and the localization, the coordinates, the latitude and longitude for that capital. We could use that information to plot a map, and we could have different information displayed there as a map. But anyhow, as an initial example here, we're going to do something as simple as plotting the coordinates or localization of each one of those cities, right? And for that, we're going to use another function from Streamlit, which is map. And map, we're going to simply inform our data frame. And as our data frame has the latitude and longitude columns, we're going to be able to do so. Here it is. Take a while to plot the map. It's an interactive map. You can navigate, and zoom in, zoom out. It's quite interesting, right? So that's the idea. Classical examples of graphs. The whole point here is that currently it's possible to create a user interface as reporting and dashboards on Streamlit directly on Snowflake. The main idea here of not having it separately is minimizing data traffic and enhancing performance, so your application will closely to your data, and simplifying the whole process, right? That's the whole idea. Even the current library that is available in Streamlit, it's an older version than the most recent one. But anyhow, I'm pretty sure that Snowflake gonna keep up to date on those libraries. So that's the main idea. Hope you like it. See you soon. Bye bye.